Let's see the simplex algorithm in action on an example from the first part of the lesson. I've changed the variable names here a little bit, so we'll let x1 correspond to the number of minutes spent doing step aerobics, and we'll let x2 correspond to the number of minutes spent stretching. I've also introduced a slack variable, x3, on this constraint for the length of the workout, and a surplus variable, x4, for how many minutes of extra stretching that our actor decides to do. And together these allow me to trade the inequality constraints we had before for equality constraints. Let's suppose that our current solution is down here in this corner, meaning that x1 is 0, x2 is 5, and our slack variable here will be 35, and our surplus variable here will be 0. The basic variables here are clearly x2 and x3, and the submatrix B of the constraint matrix A consists of these two columns here. Recall that we want to solve for these basic variables and essentially eliminate them. And here we see that we have x2 is equal to x4 plus 5 from this equation here, and x3 then must be 35 minus x1 minus x4. And of course, these need to remain non-negative. Substituting these into the objective function, I now get this in terms of the non-basic variables, the ones that I'm thinking about moving into the basis, x1 and x4. And actually, both of these have positive entries in the RD matrix. RD here just has 12 and 4 as its coefficients. Well, arbitrarily, we'll go ahead and choose x4 as the variable to bring into the basis. So essentially x1 gets automatically sent to 0, and these here then become the constraints. The negative sign here means that I could send x4 as big as I wanted to, and that wouldn't affect this constraint at all. Here, however, the coefficient on x4 is positive, so we do need to worry about this constraint, and that limits how much bigger I can make x4, only up to 35. The fact that this constraint goes tight implies that x3 became 0. So x3 should go out of the basis, and x4 should come in. Graphically, this corresponds to moving from this point down here to this one up here, with these being the new values for my x variables. And then I would repeat this process for the new basis, and eventually come down this edge here to the optimal solution.